All right. Cool. Well, thank you, Curious, for having me back. I always love coming here and talking with you guys. And I know everybody's off hacking in a hackathon, so if you can't peel away, hopefully you'll see this recorded later. We're going to be talking about APIs tonight. And I don't care if you've never heard the acronym API, by the end of this workshop, you're going to know how to use APIs and integrate them into your projects. And we'll talk a little bit about why that is so powerful. So just a quick introduction. My name is Claire Freilich, and I am a student community manager at a company called Postman. Hi, Constant Chaos. I'm going to mute you. Sorry to be rude. Um, I'm Claire Freilich, and I'm a student community manager here at Postman. And you can find me on Twitter at ClaireFro. So Postman is a company that builds a tool that helps you build, test, consume, discover APIs. And again, we're going to dive into what an API is real soon here. So here's what we're going to cover today. We're going to learn what are APIs, what's a server and a client, how to make HTTP requests to an API, and how to understand what comes back, how to authorize your request made to an API, and then, of course, how to integrate APIs into your projects. And that's the real magic, because APIs are going to give you superpowers. All right, so without further ado, what is this API we keep talking about? And why should you care? Well, API stands for Application Programming Interface. And it's what allows code to talk to code, essentially. So it's how different services can integrate and communicate with each other. So APIs help you as a developer integrate cool features that somebody else has built into your projects without having to reinvent the wheel. For example, you could send emails without understanding, how the underlying protocol of email works, just by using an API in a very simplified interface. So APIs also allow companies to open their product up for other developers to discover their data. So for example, like Twitter has an API, so any developer can tap into Twitter's tweets and programmatically collect data from Twitter. And some companies, even their whole product is an API. So you can make a business out of building an API. All right, so to better illustrate this, let's do a little analogy. You can think of an API kind of like a waiter at a restaurant. So, in the restaurant, you show up and you talk to the waiter, you look at the menu, you tell the waiter what you would like. The waiter is kind of the middleman and will go back into the kitchen, tell the chef what needs to be made, and the chef will, use their specialty skills to cook you up your dish. And then the waiter will bring it back to you. So you have just enjoyed a meal without having to know how to cook that dish, without having to, go and buy the ingredients yourself. All you had to do was say the word, and the waiter went and fetched your meal. And this is very much like the role of the API. An API creates a very simplified interface for, fetching data or asking for services to be performed, without you having to see all of the nitty-gritty back in the industrial kitchen. So you don't have to know anything about, the data structure of the database or anything. The API just gives you that very clean interface to make a request. So if we're going to make a parallel analogy, in our restaurant, the customer would be the client. For example, a browser used by you, the user, could be a client that makes a request to an API. The API is the waiter that goes back into the kitchen, which is the server, and fetches all of the ingredients and asks the chef to cook it up so the waiter can send it back. So the API is the middleman. Now, there's an API for almost anything you can think of, because today the modern web is basically run on APIs. All of these services are integrating each other's other services, because if you're really good at providing a certain service, that works really well for everyone. So, for example, you can kind of piece together applications like they were Lego bricks using different APIs. You can, for example, there's weather APIs that will let you go and fetch the weather for certain locations. You might even chain that into Discord with a Discord bot. You'll use that API to, you could fetch weather from a slash command in Discord. Twitter has an API, Spotify, you can get music recommendations. SendGrid is an email API. There's Kanye West quote APIs. You think of it, it's out there. So how did we interact with APIs? Because, of course, when you're at a restaurant and you see a waiter, it's a very visual interface and audible. But when we're dealing with APIs, that's code talking to code. How can we really get in and see what's happening in order to, make the integration work the way we want? Well, back in the day, this used to be done by developers using a command called curl in the terminal. And you could just type curl and then an API endpoint or URL, and it would go out and show you what data comes back. The tool that I'm going to introduce to you today is Postman, which is like curl on steroids, because it gives you a GUI, a graphical user interface, to really kind of like a microscope, inspect what's happening when you're making a request and what's coming back in the response, as well as gives you a lot of other features like being able to group your requests, share your requests, comment and collaborate. You can even visualize your responses in Postman. So, and I know one of the hackathon challenges had something to do with that, so this might be interesting to you. Just a quick note on Postman. Why should you care about this tool? It's becoming incredibly popular because of the convenience it provides developers, and companies are aware of that. Now there's, over half of the global 2,000 companies in the world are using Postman. 98% of Fortune 500 organizations are using Postman. So the chances are, like, by the time you graduate and you're looking for work, the companies out there are going to be interested in whether or not you know Postman, because it's becoming a very in-demand skill to know. All right, so let's talk request and response, because that's the meat and potatoes of working with APIs. So again, we've heard these terms client and server. Let's just go over that one more time. The client is going to be the entity making a request. So for example, let's say I wanted to get a list of Claire's Google contacts. The client might be an app that I made. So my app might make a request over the network to a server. And the server living out somewhere on the cloud is going to see my request and, do some processing to provide a response. It's going to go look up my contacts and send it back over the network. So it seems very simple, and it is. It's make a request and get a response. You just need to know who the players are. The client is the one making the request, and the server is the one responding to the request. So what do you need to make a request? Well, bare minimum, you just need two things. You'll need to have a request method and an endpoint or path. Additionally, you can add some parameters that provide extra details about your request. You can have headers, which are kind of like metadata about your request, including authorization, and a body, which is the payload. For example, when you sign up for creating an account on a website, you're making a request to an API behind the scenes. And that request has a payload of your name and your email, etc., all of the information on the form. And that's what goes into the body. So we're going to spend a lot of time actually hands-on today. So let's learn the bare minimum for the request. Again, like I said, you must have a method, and there are a couple of methods out there in the HTTP protocol. And these are just conventions that mainly help us as developers who are human be hyper conscious of what type of request we're making, because we care whether or not our request is destructive or not. So maybe you guys have heard of CRUD, CRUD acronym, which stands for create, read, update, delete. And these are kind of like the 4 cardinal operations that give you like a minimum viable, database interaction. So the get is kind of the read operation, and it's the safest because you aren't altering any data in the database. You're just reading data. Post request is going to send data. It's like making a post on Facebook almost. You're going to send some new data. A put or a patch request is changing existing data. So for example, let's say you wanted to edit your name on your account. You might make a patch request to change. And finally, delete is exactly like it sounds if you want to delete some data, for example, deleting an account. All right, so those are some methods. This is not an exhaustive list of the methods, but these are very commonly used ones. The other thing you need to make a request is an endpoint. And many of you have seen, you're probably more familiar with endpoints than you realize. You know that there's usually a protocol like HTTP or HTTPS for secure. You have the host, which is like the base URL, and a path. So some path on the host that specifies exactly where this request is being made. For example, we've got a Google search here. So let's just try this out in the browser first. So hopefully you can still see my screen. If we go to https www.google.com, only 3 W's. You've probably done this before. It takes you to a web page. What you may not realize is this is basically, this is your client is making a request to a server, right? When we put anything in the URL bar here, this is kind of like a human-friendly nickname for some IP address out there, right? So the DNS looks up the name and maps it to an address, and that's where the server is hit, and it gives us back some data. In our case, when we hit the google.com server, if we inspect this web page, you'll see in the network tab, I'm going to go ahead and refresh. This is all the responses coming back when we hit this page. And, Google, they send a lot of stuff. But if we can find, here we are. This is the request made to google.com. And you'll see it sends back a response that is an HTML document. And that's that's how a browser works. You send a request to a server and it sends back an HTML document that we get rendered here in the screen. So HTML is one type of data that can come back from a request. Now, we've just done this in the browser, but I want to show you that you can also do this in the tool Postman. So Postman is a free tool. You can just go to postman.com and sign up, and instantly you'll have access to Postman in the browser. You can also download it as a desktop app if you like, but I like it in the browser because it's very convenient. So I've created a workspace called Curious Demo, and to make any request, first I will create a collection by clicking the plus. And I'll just say demo is the name of the collection. And inside the collection, I'll add a request. Now, unlike the browser, we have a lot more control here because the browser is just going to make those GET requests when we type in here. But we can pull this drop down and see this huge list of other types of requests we can make. But let's go ahead and make a GET request to google.com. I'll copy this, paste, and let's see what comes back. So we get the exact same thing back that we got in the browser. And what I like about Postman is it's going to prettify. You can see it's all indented, it's colored, it's much less cramped to read than this. And I'll make it a little bit bigger. Yeah, you can read this HTML, or you can preview and see what it looks like rendered. You'll notice that a couple of images are missing, and that's because these are separate GET requests. Remember in the network tab, we saw there's a ton of requests that were made on the network. You'll have to make separate requests to get these. But you can also see more data. You can see what cookies came back in the request. So looks like we've got 2 cookies back from Google. You can see what headers came back. So remember, headers are that metadata. And, it gives the date of the request, what type of content came back. We got an HTML file. If you ever are wondering what these headers mean, Postman provides these little tooltips so that you can hover and learn exactly what each of them means. So it's a great learning tool for learning about headers. Other things you'll see in the response are the status code. We'll get into that a bit later, but 200 OK means that it was a success. You can see how long it took for the request to come back and the size of the response. So really, there's only like kind of two worlds you need to be concerned about in Postman. The upper half is where you build your request, and the lower half is where you can see all of the response details. All right. Hope we're all still following so far. So there's other things we can add to our requests. One of those is parameters. Now, parameters help us refine our request, and they add a little bit of extra data that isn't exactly the payload, but does help us, put kind of options on our request. So for example, with the Google search path, we can add a parameter called Q for query, and that's going to have our search keyword in there. And this is what's called a query parameter when it comes after the question mark. You can have these key value pairs separated by an equal sign. So like Q equals nature means like I'm searching for nature. The ampersand is going to be sort of like a comma in a list where you can list additional parameters. So for example, if this is a different API, but if you had a photo API and you wanted like only landscape photos, this is an example of a potential parameter in that API. There's one other type of parameter called a path parameter. The only difference is instead of after a question mark, a path parameter is actually part of the path. So it's slash, and then this part becomes dynamic. You'll often see this, for example, on GitHub, username. You'll say like github.com/users/me/you/somebody. So that part that's changing, that is a path parameter. All right, so let's test this out. If I were to add on here the search and question mark, that's going to start our parameters. And I could say Q, and you'll notice Postman pulled this down and makes it nice and readable in this query parameters box. So we could search for Curious Canada, and you'll see it's put the key value pair here. I'm going to hit send. And we get back something. It's harder to read this than it is to see the preview, so let's take a look. And you'll see we're getting a Google search page HTML that has Curious Canada pre-filled in. So this is how you can use query parameters. You'll notice like, hey, why didn't that break because there's a space? That's because Postman automatically encodes your URLs. So if there is a space, it's going to, change that into %20. That's the URL-friendly way of adding a space. So don't worry, this is nice because it's very human readable. All right. If anybody has questions, feel free to, turn your mic on or throw something in the workshop chat. Okay, so moving along. How do I get back to my slides? All right. Another thing we can add to our request are those headers, some metadata. And mainly, you might be using headers to add authorization to requests. Now, we could manually add a header called authorization, and there's many ways to authorize a request. And authorizing is just a way that we can make a request that requires permissions. We're going to give an example of that later. So we could manually type a header in, but I'm going to show you how Postman can help you with authorization. There's other common headers out there like cookie, if you want to specify what cookies to send over with your request. Content type means I'm expecting this content type back, for example, HTML or JSON, etc. And yeah, there's a lot of headers. Postman will give you tooltips to describe each one. Now, one thing we haven't touched on yet is how to add that payload to your request. For example, if you're making a post put, or patch request, oftentimes you're sending data to the server. So there's many different types of data you can send. For example, if you had an HTML form on your page, you can send form data. You can send JSON data. If you aren't familiar with what that looks like, JSON stands for JavaScript Object Notation. So it's just a way of representing data in key value pairs that looks a lot like a JavaScript object. So you just have these keys that are strings and a colon pointing to the value, which can be, a string, a Boolean, a number, or an object, including, you can nest your objects and arrays inside of JSON. Of course, you guys are familiar with HTML. You can send XML, you can send whole binary files. You can make GraphQL bodies. I'm not sure if any of you are familiar with GraphQL, but it's another format for, it's a query format for making queries to APIs, and many more. All right, so what about a response? Well, we won't go too heavily into this because we did a little example earlier, but you saw that we can get a status code back telling us the result status of our response. We can get headers back, and we can also get a payload back from the server called the body. So quickly about status codes. They're designed in such a way where if you know the first number of the code, you have an idea of what type of status the response was. For example, any 200 range code, such as 200 OK, 201 created, 204 no content, these are success. That means the request went successfully, and it's a thumbs up from the server. They have different flavors of success. For example, 204 means yes, it was fine, and no, I'm not sending you anything back, just know it's A-okay. 200 might have some sort of message that comes back, but still, it's okay. Then we have 300 level status. So anything that starts with a 3 has to do with redirection. For example, you make a request to some API, but the API's endpoint had moved. This is going to let you know that. Or if you're being redirected someplace, it's a 300. A very important one are the 400 level status codes. This is client error, meaning I did something wrong as the client. For example, if you use the wrong data type, like you posted a number as your name, or if you're not authorized. For example, I tried to access Leo's private repo on GitHub. I would get 401 unauthorized and no data would come back. 403 forbidden. Actually, that's more like if I was trying to access Leo's, I'd get forbidden. And of course, many of you are familiar with 404 not found. That means you requested something that doesn't exist, and we have nothing to show you. Lastly, and very importantly, are 500 errors. This means it's on the server side. So that could mean the server is on fire and it blew up and something went wrong, but whatever it is, the server was unable to communicate. Maybe you've seen like 502 bad gateway or 503 service unavailable if a server is shut down, or 504 gateway timeout if you send a request and it's taking ages for it to come back. Some servers are coded to just give up. So you don't have to memorize this chart, especially since in Postman, if you're using it, you can always hover over the status in the response, and it will give you a nice paragraph about what exactly a 200 is or a 201. So this is another great learning tool for learning your status codes. All right, so we've talked a lot of theory. I want to spend the bulk of our time today diving into using a real-world API, and we're going to use the GitHub API. So I'm sure many of you are familiar with GitHub. It's a place to store and collaborate on your code repositories. I hope many of you have an account because you'll be able to try this out yourself. But I'm sure many of you are used to using GitHub, the website. You can click on the website to create repos, etc., search for repos. Today, we're going to use GitHub's API, meaning we can programmatically interact with GitHub. So GitHub has documentation, if I could click on it, for this API. And we're going to take a quick look. So you'll find very quickly when working with APIs, reading documentation is an essential skill. So we're going to take a quick look together about what you'll see if you hit the GitHub REST API documentation. Of course, you want to start in the overview and take a look at the first article, because this is usually where you learn how to get started. And you can see here, there's stuff about what version the API is. Mainly, we want to know, where do we make a request to this API? Well, we see right here that we get the host, the base URL of this API, which is api.github.com. Great, so now we know how we can make a request, but we don't know any paths or what types of things we can do with this API. That's where references usually come in handy. So here you can see all of the things that we can do with the GitHub API, and it's broken down into these kind of subcategories. So for example, if I click on repositories, I think it takes a second to load because there's so many actions you can do with the GitHub API. But we should get a list of endpoints that we can hit on the GitHub API to perform certain actions. Now, there's a ton of stuff on this page. It takes a long time to read through it, but you can find on the right-hand side a quick menu that will take you exactly to what action you want to perform. So, for example, if you wanted to list repositories for a user, take a look at that. It tells us, okay, we need to make a GET request, remember, like a read request, to this path, /users/username. This is dynamic, a path parameter, /repos. And it should give us data. So less reading, more trying. Let's go ahead and grab that base URL right here. And we're going to head over to Postman and try this out. So I'm going to make a new collection called GitHub API. And inside the GitHub API, we're going to detail which actions we'll try to perform. First, let's say this one will be to get user info. So I'm making a new request inside the GitHub API collection. We want to make a GET request. And first things first, I'm going to paste that base URL, which is the start of our endpoint. Now, let's go check the documentation and figure out how to get user info. Let's see if they have an API for users down here. And over on the right, get a user. So GitHub provides publicly available information about someone with a GitHub account. So here's the endpoint, get/users username. And it tells us exactly what parameters we would need to pass to make this request. Now, the only required parameter here is username, except in the header is a suggested parameter. But since Postman automatically accepts any type of response, we don't have to add this. So all we need to do is add in our path the username. So I'm going to head back here, slap this path onto our endpoint, and username is what we have to replace. So for example, Octocat is the official GitHub mascot repo. If we make a request here by hitting send, we've gone and made a GET request to GitHub server on their API, and their API has sent us back some data here in our response. Here we can see we've gotten back a JSON object that has a bunch of key value properties. For example, this is the login name. You can see the account ID. You can see the avatar URL. And if I click on this, actually, it's going to open a new tab in Postman so we can make another GET request and see what exactly that avatar is. Very cute. But that's not what we're here. I'm going to go ahead and delete that. Yeah, you can see the location is in San Francisco, all of this data, like you can see how this is handy. For example, say you're making an application that collects an overview of a user's GitHub activity. You could use the GitHub API to go out and fetch how many public repos they have, how many followers, etc. Or even when they've joined GitHub, you can see here. So you can start thinking about how you might integrate this into an app that you make. Now, anybody in the chat that's still listening, feel free to put your GitHub handle in the workshop channel, and we can go ahead and real time use the API to look at your stats. Is anybody brave enough to share their GitHub handle? Crickets. All right, Andrew 059. I'm going to go ahead and copy. And here, before we had hard coded this into the path up here, Postman gives us a feature where we can use a colon and just give that property a name, that path parameter a name. And if I scooch this down a bit, you can see Postman has added a cool little table that gives us a key value pair. So in here, I can paste Andrew's GitHub handle. Now I can read, oh, this is a username, and it's going to resolve to Andrew. So let's go ahead and send this. And we get back Andrew's stats. We can go ahead and take a look at his avatar. Very creative default avatar. We can see that Andrew has 10 public repos, is following 17 other users, and that's about all we can get on Andrew. What about Mini Apple? Let's take a look at Mini Apple here. So now, instead of like retyping up here hard-coded, all I have to do is replace this value down in our path variables. So I'm going to go ahead and send. We've got Mini Apple's account here. We can check out Mini Apple's avatar. Very cool. And we can see it's Emily's account, 24 repos, 7 followers, 7 following, and been a user since 2016. So this is real data that we just got for free very easily without even visiting the GitHub web page. Pretty cool. So what if I was to look up my own? Or actually, let's go ahead and look at, we saw Emily here has 24 repos. We can even take a look at what those are. If I want to make another request in Postman, all I have to do is click the dots, and I can duplicate this current request. So I'm going to go ahead and duplicate it. Here, this time, we're going to try to get user repos. Now, we've duplicated the request, and we see there's something common to these two requests. It's using the same base URL. And Postman helps you avoid repeating yourself by letting you use variables. So I can store this whole base URL, which keeps getting repeated in all of our requests, as a variable by highlighting it. And Postman gives me this pop-up that says set as variable. I'll click on that, set as a new variable. I'm going to call this base URL. And then it gives a value of what we just highlighted. Now I can select a variable scope. So there's different scopes that you can resolve your variable to. Global is going to be available in this whole entire workspace. Collection is going to be available on this collection folder. I'm going to go ahead and click that one and set variable. And you'll see it's been transformed into this double curly brace with the variable name. Now, if I hover on the base URL here, you'll see it's resolving to the value we just saved. So now, anywhere in this collection where I say double curly brace base URL, it's going to resolve to this value. So I'm going to go ahead and copy this and replace our previous request with the same. There we go. Click save, save. Now, I can hover to see what this is, but if I want to confirm what current collection variables I have, I'll click on my collection, head to the Variables tab, and I can see right here we have the variable called base URL that has the value api.github.com. You may be wondering, why is there 2 columns here? And that's because oftentimes when you're working with APIs, you're going to be dealing with sensitive data. Now, sometimes you want to share variables with the public or your teammates, and sometimes you don't. For example, if you're entering a password or an API token. Those are things you want to keep hidden. So anything that you're okay with sharing can go in the initial value column, and if somebody copies your collection, they will inherit that value. Or if you want to keep something private, only put it in the current value column. So Postman's going to use whatever is in the current value column. This is kind of local to your Postman. All right. But in our case, it's okay that GitHub is public. This is a public URL. All right, so let's get back to our mission. We are going to try and get Emily's repos. So let's go back to the documentation. This is a repo activity. So let's go to repositories, the page that takes forever to load. Oh, actually, I believe we can do it on the users. So let's go ahead. See, get a user. If we search for repos on here, let's see, Control F, repo. Well, I know I've done this before, that you can say here, if we put the username and we go ahead and grab mini apple, or copy and put mini apple as the username, and then we can say repos. This is kind of like drilling down into the user's repos. So let's go ahead and make the get request. Here we're getting back a bunch of repos that belong to Emily. So I can see there's one called Blackjack here. It's a public repo. You can see all of this detail about, of course, the user that owns the repo, but also the fact that it's not a fork. It was created entirely by Emily. You can see tons of data, lots of links to different, locations in the repo. You can see who's watching it, the size. You can see if it has any issues, it does, what language it's in. Like all of this data you can get from the API. And sorry to put you on the spot, Emily, but thank you for letting us use your account. This is really a handy tool. Like say you're trying to make an app that analyzes somebody's GitHub activity. You want to know what % of their repos are in Python, or how big their whole entire code base is on GitHub. You can use the GitHub API to get that information. All right, so up until now, we've been getting data that's obviously public. I'm not Emily, but I can see Emily's content here. If we want to do read stuff, oftentimes, yes, we can do it without authorization. But if we want to do more mutations of data, such as like creating a repo, forking a repo, updating or deleting a repo, oftentimes you're going to have to do what's called authorization. I can't just delete Emily's repo. I'm not authorized to do that. But I'm authorized to control the content on my GitHub. So for example, let's say we wanted to make an API request that forks a repo. I'm going to add a new request and call it fork a repo. And let's learn how to do that. We'll go to the GitHub documentation, go to repositories. This page has so much text on it, it always takes a little while to load. All right, so let's go to the right-hand menu and try to find something about forks. There's so much stuff you can do with this API. Forks, all right. Create a fork. So this request creates a fork for the authenticated user. So that's the user that has the permission to make the request. It's a post request, which makes sense because we're actually creating new data in my account when we make a fork. So here's the path. We do /repos/owner/repo/forks. So this is probably the owner and the repo name of the repo that we want to fork. Not us, but the source repo. And then it also takes some parameters. So obviously we have to fill in these path parameters. And there's some optional ones as well, it looks like. For example, if you had the Curious Hacks organization, you could add that on here and it would make a fork to Curious organization instead of my personal repo. So let's try this out. Now that we've saved our base URL as a variable, all we have to do is double curly braces, base URL. We've got the github.com API link. Now we just paste our path. Remember, this is going to be a post request, so let's change the method to post. And here we'll use that Postman trick using colons so that we can cleanly update the path parameters. Now all we have to do is think of a owner in a repo. I know that there's an kind of a hello world repo out there on GitHub. Yeah, on the Octocat account, there's a hello world repo. Let's go ahead and fork this one. It's just a README file that says hello world. So it's Octocat is the owner, and the repo is called hello world. I'll copy the repo name. Or not, I'll just type it. All right, so owner, Octocat. And repo is hello world. All right, what do you think is going to happen if I click send now? Any guess? All right, well, I'll destroy the anticipation by hitting send. Uh-oh, we got an error. It says you must be logged in to do that. Obviously, like I'm just a random person calling the API right now. The API has no idea who I am. How does it know where to fork my repo? You'll notice here we get a status 401. Remember, 400 level errors are client errors, meaning that the person making the request made a mistake. That is, the mistake is I forgot to give them my credentials. So now we get into auth, authorization and authentication. How can we authorize the API? Well, we usually do that using headers. And here, every API is different. You'll have to look at the documentation, but oftentimes you'll type like authorization, and the API, you'll either have like a token, or you might do some sort of like username password situation to log in. But Postman, Leah just asked a good question. Does GraphQL have error status codes? Yes. So this status codes are part of the HTTP protocol. And remember, HTTP, you can send many different types of data. GraphQL, you can send JSON, you can send a file, etc. The response that comes back from the server is going to have a status code regardless. So yes, whatever type of HTTP request you make, you're going to get a response back. All right, so we were talking about authorization and authentication. You could, do this in here, or Postman gives you a helper. You'll notice there's an authorization tab, and in here, you can choose from many different types of auth. Now, different APIs, again, have different types of authorization. I've gone ahead and read the GitHub API, and I know there's two ways to authenticate. One is with OAuth, which is a complicated dance that involves getting an access token. Another way is what's called basic auth. This is the example I'm going to show you today. So we can just click basic auth, and you'll see it's Postman's asking me for a username and password. So this is handy because Postman's going to take care of encoding this into a base 64 string so that it's kind of obscured when you send it over the network. But how does this actually work? Well, we'll put in my GitHub username. And for the password, GitHub asks that we use a personal access token. Now, it's very easy to create a personal access token. We can head to GitHub. If you go to your settings in your account, I'm going to make this a little bit bigger. You can scroll down to developer settings, and you'll see personal access tokens here. And I made one earlier today, and I'm going to keep that a secret because tokens should always be treated like they're precious passwords, because they are. These are the keys to making things happen in your account. If you had my token, you might be able to delete all of my repos, and I'd be very sad. So I'm going to keep that a secret, but I am going to show you how you make a token. So you just click Generate New Token. You sign in, and you can then name your token. So I'm just going to call this one Test. Now, as a security measure, tokens automatically expire in a month. You can even make that shorter if you'd like, or you can say no expiration. But I do recommend that you take the most security precautions as possible, because if your token gets leaked out there and somebody gets a hold of it, they have the keys to your kingdom, depending on what permissions you've added. So always be careful with your tokens. Always err on the side of the minimum permissions and using expiration to be secure. All right, so after you choose an expiration, you're asked to select some scopes. And this is another mechanism for ensuring that it's not like on or off. You have the key to everything or you don't have a key. You can customize what exactly this particular token has permission to do. So with this token, we would like to perform all of these repo functions, such as getting a repo status, seeing public repos, etc. I don't think we need to do any workflow stuff. Writing packages, maybe we're gonna add some files, deleting packages, sure. All this admin stuff, I don't think we need. Writing gists, not the scope of today. We want some user info to come back, yes. And deleting repo we're gonna do later. So this is all you would have to do. You want to choose the bare minimum that you need to accomplish your task. Be as secure as possible. Then all you do is click generate token. And now if you copy this really quickly, you can delete all my repos. But this is the only time that you'll see your token. So you want to copy it now and put it in a safe place. I'm going to delete this right away because I don't want you guys deleting my repos. And now that key is inactive, so even if you did take a screenshot, you can't delete my repos. All right, so that was just a demonstration on how you make a personal access token. I have mine over here that I'm just going to paste in. And I'm not going to do that on screen because I don't want you to see. But before I do that, I want to tell you, you don't want to hard code stuff here, because if I were to save this request and then share this request to somebody like a friend or a teammate, my access token, my personal access token, would be out in the open. Anybody could see it. So again, just like we use variables for convenience up here, we can also use variables to hide sensitive information. Now, instead of doing all this auth on the request level, so we're down here in the fork or repo request, we can actually do it on the entire folder. So if I click on our collection, we'll also see an authorization tab. It's the same content as before. The only difference is if I fill it out on the collection level, the auth is going to apply to every single request in this collection. So here, I'm going to go ahead and make a variable called username. That's going to be our username value. And in the password, I'm going to say personal access token. So these are variables, and if I hover, it says unresolved because we haven't given these variables a value yet. So remember, we can give value to our variables in the variables tab on our collection. So I'll click here, and I'm going to add username, and I don't care if this is public, so I'm going to put it in both. Now, personal access token, I'm going to paste it not in initial value because I don't want this to be shared with other people, but I am going to paste it here, and I'm going to do that off screen so that you guys don't steal my access token. All right, I've pasted it and saved. Now, if I bring back the screen, you can see these values have been populated. So if I hover over username, it should say Clairefro, yep. And my password is also a variable, so I could say show password. And if I hovered, you'd see it, but I won't show you. Just know that the value is populated. All right, so now you'll notice all of these requests, if you click on the authorization tab, they default to, can I make this a bit wider? It says the default mode is inherit auth from parent. It's a cutoff, but trust me, that's what it says. So by default, any request inside of our collection is going to use the auth that we gave on our collection. So now that my username and password is in there, I should be able to make this request to fork the Octocat repo. Let's go ahead and give it a try. What do you think is going to happen this time? Do you think my computer will blow up? Do you think we'll get another 400 error? let's see. So I'm going to go ahead and send. Make sure that we're inheriting the auth. We need to do that. Inherit auth from parent. Click send. All right, we got a 202 accepted response back, which means it's been accepted for processing. And the processing has not been complete. And we notice that in the documentation, it says, note, forking a repository happens asynchronously. You may have to wait a short period of time before you can access the Git objects. So yes, it was a success. We know that because it's a 200 level response. And we even got data back from the API. This is the name of our new repo. And now it lives in my account. So it's Clarefro Hello World. And it has all the details about me and the fact that it's got no issues, no watchers or anything because it's a brand new fork. So this is pretty cool. We've created a fork in GitHub. If you don't believe me, let's go ahead and take a look. If I go to your repositories, there we go. We've got Hello World here. This is what we just created without using the website at all. So yeah, that's pretty cool. You could fork repos all day. You could get GitHub green squares without using GitHub at all, just by making an automated commits using the API. All right. So now I decided I don't like the name Hello World. I don't like having capitals in my repo names. I'm going to go ahead and duplicate this request. And let's try yet another. This is going to be to update a repo. And how do we do that? Let's see here. It says we're in the repo section. Is there any updates? Create or update environment, update our invitation, update a commit, update a repository. Okay, so we see yet another method is used here. We make a patch request because we're updating existing data. And here's our path, repos/owner/repo. And it tells us these are all the things that we can put in our body or path to update. These are our parameters. For example, if I want to change the name of the repo, I'll just give a body with a name property of the new name that I want my repo to have. So I've copied this endpoint. I'm going to go ahead and paste it into our new request. Oh no, that was my access token. You didn't see that. Okay. Going to actually copy the endpoint and paste it. There we go. We're going to use that Postman trick with the colon to make our path parameters all pretty. And now the owner is me. And the repo we're trying to change is hello world. Now remember, it asks that we add a body to this request. So the body can be added here in the body tab. And it needs to be a JSON body. So I'm going to click raw, change the data type to JSON. Open and close the brackets. And in here, remember the property had to be name. And this is going to be a string that is the new name of our repo. So let's say, I'm just going to call it updated with the API. Creative new name. All right, so now, again, this request is authorized with my account. So I'm logged in as me. I can go ahead and click send. And we get a status 200, okay. That means a success. We can see the new name of the repo is updated with the API. If we want to check and make sure, I'm going to go ahead and refresh this page. And yes, now it's called updated with the API. Awesome. But ultimately, I've decided this repo is useless and I'm going to delete it. So let's do one last demo request to show how you delete a repo. And that's interesting that they let us do this with a post because the documentation said it should be patch. So I made a mistake there, but GitHub was forgiving and they did it anyway. All right, so one last request. Let's duplicate and name this delete a repo. Okay, and let's check the documentation. Let's do a search for deleting. Ooh, right below. So a delete request is going to take the delete method, and it has the exact same path as our previous request, and it doesn't require any body or anything. We just send delete this repo, please, with our authorization. All right, so we're already filled out here. Our repo name has changed to updated with the API. And we don't need a body, but we do need to update this to a delete request. Okay, so I'm going to go ahead and send this off. Let's see what happens. That is 204, no content. So 200 level means it was a success. That's good. I can prove that by trying to refresh the page. And we get a 404. Remember, 400 level errors are client errors. 404 means not found, and that makes sense because we just deleted it. Likewise, if we tried to use the API to delete the same repo again, the API is going to tell us, hey, 404, that doesn't exist. What are you trying to do? So that's kind of a tour of the get, post, patch, delete, basic CRUD operations that you can perform with the GitHub API. That's all well and good, but you might be wondering, okay, why would I want to know this? How could I use this in my projects? Well, Postman has a very handy feature called Codegen, code generation. So for any request, for example, this get user info request, you can click over in the far right at this little code symbol, and you'll get a drop-down menu to automatically generate code snippets. So for example, if you were building a JavaScript project and you're using the fetch library to make an HTTP request, all you have to do is copy all of this code. Postman's already added all the headers and the authorization that you would need to make the exact same request in JavaScript or a host of other languages. So, you might have a Node app, you could do it in C. I know a lot of you are Python programmers here at Curious. You can see what it looks like in Python. If you're a fan of the terminal, you can always curl it. So this is a very handy feature that shows you exactly how you can pop these requests that you've built in Postman and test it out right into your apps. So that is about it from me. I just wanted to show you what APIs are, how to make requests, how to interpret responses, and how to integrate these types of features into your projects. We can open up the floor for Q&A in just a second, but before I do, I just wanted to introduce one opportunity that might interest you at Curious. If any of you are excited about APIs and wanting to learn more about how you can use Postman to play around with them, we have a free training called the Postman Student Expert Training. And it's like a self-paced thing. You do it inside Postman, and it takes, less than 2 hours. And by the end of it, if you pass all the tests, you get a digital certificate, this badge here that you can share on LinkedIn or social media. And it's great for you because now employers are very interested to know who knows how to use Postman. So if you're interested in, of course, enabling yourself to have these API superpowers, go for it. You get the bonus of also getting a badge. I've also created a collection on Postman that anybody can access that has all of the requests that we did today. If you want to copy this collection by forking it, all you have to do is navigate here with your Postman account, click the dots, and say create a fork, and it's going to ask you where you want to fork it to in your workspace, and you can then play around with everything we did today, plus some extra ones I added in here. So yeah. That's all from me. Let me know if you have any questions. Question from Leo. What is the difference between an API, ID, slug, and query params? And what are the different use cases? Great question. So those are often easy to get confused. Let's take a look at a couple of examples here. I'm going to make this a bit bigger. All right. So when we make a request, we have different ways of entering params. And Leo's mentioned ID, slug, query params. So ID and slug are kind of categories of different query params. But what you need to know the difference is a query param and a path param, right? So path param is going to come after a slash directly. For example, username here is a path param. This whole chunk of the path is dynamic. This can be, Clarefro, this can be Minneapple, this can be whatever. The whole path is dynamic. If we're talking query param, that's when you see like the question mark come into play. So it might say like, I don't know what kind of option you might have on this, but name equals foo, right? And if you want to have multiple query params, you separate them with an ampersand. So if I say and bar equals baz, right? These are now key value pairs. So what are the use cases and the difference is your question? A lot of it is convention, because technically you can use query params for, GitHub could have designed their website that you go to users and say name equals foo as the username or Clarefro. GitHub totally could do it that way. But the convention is to use path params for IDs, and a handle is a user ID. Same with slugs. Oftentimes query params are used kind of for options. Like if you're hitting an image API and you only want to get images that are like 500 by 300 pixels, you're probably going to use like two query params, the height query and the width query, right? Yeah. But it's not hard rules. Like anybody can design an API however they want, but conventions are key. So great question. Do we have any other questions? I know it's a bit late. I'm also going to pop a survey into the workshop chat. So I'd really appreciate anybody giving any feedback on, what went well or what can go better. So while I'm typing the survey in, feel free to ask any more questions, and mics on are welcome as well. Oh, sweet, I just advanced to level 3. I guess I'll also share the slides. So Emily asked, what's my job as a student community manager? So my team's mission at Postman is to promote API literacy. And that means like making developers like you all excited and capable of integrating APIs in your projects and building APIs. So my job as a student community manager is doing exactly this, coming and doing workshops, setting up the trainings that we have to enable students to learn and show off their learnings. We just organized a huge online summit, the Postman Student Summit. Our videos will be up on our website soon if you want to check them out. But that was a whole host of API talks from students, from educators, from like professors at universities, the developer advocates at like Twitter and Free Code Camp, like really trying to get people excited about and confident in using APIs. So it's kind of an education role. At the same time, I still get to play with code. I get to build APIs, and I love being in both worlds doing that. Any other questions? I'm going to go ahead and share the slides for API 101 too, in case you want to follow along. A quiet night. All right. Well, thank you all for coming. Thank you, Emily, for thanking. And yeah, feel free to fill out the survey, anybody that stuck around. And happy hacking. If you have any questions about APIs, even if you're using it in the hackathon now, feel free to ping me in the Curious channel, and I'm happy to help you overcome any obstacles. All right. Happy hacking, y'all.